Good evening, Accelerated Math. After all those weeks and weeks and weeks of just calculating, multiply, divide, add, subtract, decimals, fractions, long division. I tell you what, we have done a lot of calculating, and it's time for something brand new. So we're going to start a unit on ratios. If you want to designate this a whole new section, we're out of the calculation unit onto a new topic called ratios. R-A-T-I, bad handwriting, O-S. So our first topic today is what are ratios and how do we represent them. So take a moment and make a title page and make a new page for today's lesson and unpause when you are ready to go. All right. So let's talk about what ratios are. So you actually already know. We did a problem the other day about snack mix. And the snack mix problem I showed to you because it kind of made you deal with ratios even though you didn't know you were doing it. If you remember back to the snack mix problem, the guy made snack mix and he made it in this equal set of ingredients, right? His recipe was 5 scoops of granola and 3 scoops of candy. And that was how he made it, right? And so he was able to fill, I think, 2 cups up with that. And he ended up needing to make 12 sets of this, right? So this kind of made 1 bowl. And if he'd made another bowl, he would have done 5 more scoops and 3 more scoops, which would have been a total of 10 scoops and 6 scoops. And he made another bowl, which always stayed in this same it's called a ratio of ingredients. Always 5 of this and always 3 of this. That's a ratio. A ratio is a relationship between 2 quantities that stays fixed. A ratio between 2 quantities that stays fixed. So this problem you did before, this was a ratio. And so I want to show you the ways we represent ratios coming up on the next page. So you have seen one, and actually, you know what? I'm going to do an extra I do. I didn't plan on this, but I'm going to do it now. So let's talk about the snack mix problem, and I'm going to show you the 4 ways that we will. This is your first I do. I'll do 2. The 4 ways we represent a ratio. So this, I want to do this one: 5 scoops granola and 3 scoops of candy. Okay. So the first way we represent a ratio is with a colon, a punctuation mark, from language arts that looks like that. It's called a colon, right? And I could say that the ratio of granola to candy is 5 to 3. And I could also reverse that and say that the ratio of candy to granola is 3 to 5. It doesn't really matter. But what this tells me is to make sort of one batch of snack mix, I'm going to have 5 groups of this for every 3 scoops of this, and 3 groups of this for 5 of this. And it's going to stay fixed in that ratio. That's one way. Another way we represent is with the word 2. You'll often hear people say, word it in just vocally like this. They would just say 5 scoops of granola to 3 scoops of candy. or just 5 to 3. And again, you could reverse it this way. You could have said 3 scoops of candy to 5 groups of granola. It doesn't matter if you reverse it. So one way is with this little punctuation mark here. One way is with the word 2. It's a 5 to 3 ratio, we would say. 5 of one, 2, 3 of the other. Another way is with a chart. And with a chart, we kind of show multiple sets of the ratios. So if you want to think about it, as this guy made granola to candy sets, in a chart, we kind of show multiple groups of the ratio at a time. So I'm going to say, like, I could use 5 scoops or with 3 scoops. Or if he made 2 bowls full, he would have made 10 scoops of granola to 6 scoops of candy. If he made 3 bowls full, he made 15 scoops of granola to 9 scoops of candy. If he made 4 bowls full, it would have been 20 scoops of granola to 12 scoops of candy, and so on and so forth. And I think we realize that in the end, if he did it 12 times, I want to say he used 60 scoops of granola to 36 scoops of candy in the end. And so a chart shows you the ratio over and over and over and over again. And the last way is with a fraction. Lots of times ratios are shown as fractions, so we could say the ratio of granola to candy is 5 to 3. Or we could say that the ratio of candy to granola is 3 to 5. That's all the different ways to show a ratio. Let me do one more just so you get a little used to this before you write these down. Recipes are common ratios, so I picked another recipe question for the I do. Recipes almost always come in ratios because no matter how many batches of stuff you make, you have to keep the relationship of the 2 ingredients kind of fixed together. It's got to come in the same amounts. So the recipe for a batch of chocolate chip cookies requires a ratio of 2 cups of flour and 3 cups of chocolate chips. So I can represent that ratio with a colon. I can say that the ratio of flour to chips is 2 to 3. Or the other way, the ratio of chips to flour is 3 to 2. Those are the same thing. I just have to make sure I'm clear which one I'm talking about. I can also do it with words. I can just say it's a 2 to 3 ratio. Or a 3 to 2 ratio. Either one. I just have to make sure whoever I'm talking to or communicating to knows which goes with which. You can do it with a chart. So think about batches of cookies, right? If I'm going to make maybe more than one batch of cookies, that's where the chart really gets handy with a ratio. Because if I'm just going to make one batch of cookies, I need 2 cups of flour and 3 cups of chips. But maybe, a couple of friends are coming over. I need more, so I want to make 2 sets or 2 batches of this ratio. So then I would need 4 cups of flour and 6 cups of chips. Or maybe I'm having a birthday party and I need even more. And so I might need a third batch where then I need 6 cups of flour and 9 cups of chips. And so on. I can keep on making more and more batches since I know the ratio. Just like the snack mix guy made a bunch of bowls of this stuff. That's an 8, by the way. And last but not least with a fraction. So I can say the ratio of flour to chips is 2 to 3. Or the ratio of chips to flour is 3 to 2. That's it. Those are all just 4 different ways to show the same ratio. Let's do one together. It's kind of a sad one. Ladies, brace yourself. True fact, the ratio of men to women science professors in college is 4 men for every 1 woman. Very sad. A lot more men are science professors than women. And so let's show this ratio 4 different ways, all right? So first is with a colon. I can say the ratio of men to women is 4 to 1. Or I can say that the ratio of women to men is 1 to 4. Those are equally okay. Doesn't matter which, you've just got to be clear. With words, I would say there it is a ratio of, I would just kind of say a ratio of 4 men to every 1 woman. And this 2 is the magic word. That's a ratio word, 2. Because a lot of times you would just say the ratio is 4 to 1 or 1 to 4 if you wanted to flip it around. So 2 is kind of a magic word that you're kind of talking about a ratio. So with a chart, you start thinking about groups or sets, right? So like let's say men and women. So if we're thinking about, say, one college, they might have 4 men and 1 woman. If we think about 2 colleges, we're thinking about 2 sets, right? So 8 men and 2 women. If we think about 3 colleges, we're at 12 men and 3 women. 16 men and 4 women. So kind of like you think about how many sets of the ratio you're going to make. And last but not least, you can use a fraction. You could say the ratio of men to women is 4 to 1. Or, of course, the ratio of women to men is 1 to 4. All right, and that's just 4 ways to represent a ratio. A ratio is 2 quantities that are related and their relationship stays fixed, stays the same no matter how many batches or sets or instances or colleges I make. That's a ratio. We will do 2 more tomorrow, and I will see you then.